Hello, welcome everyone to today's talk. And my name is Olga. I'm platform engineer in ANZx. And yes, ANZx is a little bit different. It is a digital transformation program in ANZ where we build a new digital bank from scratch on cloud native, on public clouds, and implement necessary practices. And so latest and greatest tech and exciting stage of the project as we launched to the market last year. So prior to ANZ, I worked with the Kubernetes distributions on AWS and Azure, and I always curious what happens on the other clouds. And I'll touch a little bit on other clouds as well, but ANZ Plus runs primarily on Google Cloud, so GKE will be the focus of today's talk. Before we go into the clusters, let's talk briefly what Spot Instances is. Spot is a provisioning model of compute resources where the capacity is provisioned out of the excess capacity of the data center. They come with significant discounts, but they have no availability guarantee whatsoever. They can be preempted at any time, and you have only very short time to finish all what this VM was doing and keep moving. Price fluctuates according to the demand for a particular instance type in a particular region, and the discount is quite significant. It can go all the way up to 90%, at least according to the documentation. And yeah, it's a good cost savings opportunity if you can tolerate a little bit of instability or if you can implement proper fallback mechanisms. ANZ Plus launched to market last year, and at this time, production cost was not a main concern for us, but our non-production by this time was massive beast. We had so many environments and tiers in each environment and cluster in almost every intersection of this. And we wanted to get this cost under control, and as you can see, Spot Instances is good. Is very good opportunity to try and do this. So we tried, and we switched our non-prod in 2 phases. All of our clusters, we moved it to Spot, and today I'll share some of the lessons that we learned along the way. What to expect from today's talk? I think when we talk about running a workload on top of Spot instances, there is 2 main things that you need to solve for is capacity availability and handling the preemption, which is graceful terminations. But I have only so little time today, and I think these 2 concerns are already very well covered in the internet. There is well-known patterns, there is open source solutions, there is commercial solutions that exist to help you there. But instead, I want to focus on unknown unknowns, things that you didn't anticipate, things that took you by surprise. And I think that would be more helpful, or at least more interesting. And unknown unknowns can be very different for each organization, and I can only speak for what we saw so far. But let's start quickly with these 2 main topics. Spot capacity management in Kubernetes is usually done by using a mix of Spot and on-demand instances, node pools, and some magic on top of it that manages these capacities according to constraints and requirements. And some examples of this is priority-based expander. Expander is a concept of cluster autoscaler that defines strategies based on which it will select which node pool to expand, to scale up. There's other example is AWS developed open source high performance cluster autoscaler, which is called Carpenter, and has built-in features to manage Spot capacity. Now, these 2 examples don't really work on GKE. So Google Kubernetes Engine clusters, the cluster autoscaler that comes out of the box with the GKE, it is price optimized by default, meaning if you have few node pools that stand in the requirements of your pending pods, the cluster autoscaler will select the cheapest option by default. And if it is a Spot node pool, then that would be Spot. Another technique is to reserve capacity in your cluster. The cleanest way probably would be to use the configurability of cluster autoscaler if it is available in your distribution. In GKE, there are two profiles. There is balanced and optimized utilization. Optimized utilization will end up with the cluster where almost each node runs at close to 100 capacity, whereas balanced will try to reserve some capacity there. Now, if your cluster autoscaler doesn't support this option, or if it is not enough, then you can implement also something which is known headroom or balloon pods, which means you deploy a dummy deployment which runs on very low priority, and when your real workloads require capacity, they can evict them based on priority. And as I mentioned, there is also managed commercial solutions, and one example is Spot by NetApp. There's many others, but this is the one that I'm familiar with from my previous experience. And I wanted just to give you an example of what is possible to achieve with Spot instances. What they offer is managed data plane for Kubernetes, which employs machine learning and predictive algorithms to proactively replace VMs before they're being preempted by the cloud. And by doing so, they're able to provide enterprise SLA when they run it mainly on Spot capacity. Graceful shutdown. First things first, you need to identify which application can run on Spot instances, because not any application can be preempted at any time of its lifetime. So examples like interactive web service, stateless workloads, or batch processing, some of these applications can be made fault tolerant. What you need to do is this application should implement handler or listen on SIG-term. SIG-term is a signal that is sent by operating system to the processes that are running on the system, notifying them that they will be soon shut down. When that happens, your application should stop receiving any new work and handle whatever it has at hand to the best of its capacity at this point. For example, if it is an interactive web server, it should send back the responses to in-flight requests. If there is connections to the external services, especially database, they should be closed properly. And whatever your app-specific requirements could be, like, for example, saving something to the bucket or sending a message to PubSub or things like that. In Kubernetes, there is a feature that is called Node Graceful Shutdown. This is implementation of the shutdown on the node. It is doing few things, but the most important things are it's marking node as not ready, and this helps not to schedule new pods on this node while it is shutting down. So it helps a little bit with overall reliability or availability of other applications. It also manages the SIG-term propagation. So it will send the SIG-term first to your workload pods, giving them on GKE, they will give it 25 seconds, and then it will leave 5 seconds to the system pods to shut down. Now, in upstream Kubernetes, these numbers are configurable, but GKE being managed solutions and having just 30 seconds for preemption, there is not a lot of wiggle room anyway. So these numbers are hard-coded, and meaning your applications need to be able to finish whatever they're doing with 25 seconds. And now this is what I wanted to talk to you about. These are the known unknowns that we've encountered. So what are we looking at here? There's examples, there's few snippets of a view of a Kubernetes namespace where we started to see a lot of erroring and confusing statuses. And there's two pain points about this. First is the overwhelming amounts of these error statuses, because these particular error statuses, you can see them on any cluster, including on demand, but you just start to see them a lot. And second is how confusingly it is presented in the Kubernetes client, so like in user interfaces. For example, here, this is a snippet from Google Cloud Console. You come to work, you open console, and you see pages of deployments, all with the red exclamation mark next to them, and some scary statuses. And in this case, this is deployments that look like they all failed out of CPU. This is very scary because consider that it's not only technical people who are looking at this, and everyone knows that now we are running on Spot, and capacity is #1 concern. So what does it mean? We lost all the capacity and we can't get any CPU in our cluster? Then there is completed for Ingress Gateway. Does make any sense for something like Ingress Gateway or for any deployment? Deployment is a forever running web server. It just doesn't make sense to be completed. Node affinities, I will get back to these ones. And many more. Now, at least with some of the other statuses, when you describe them, what you'll see the message that says pod was terminated in response to node shutdown. But with node affinities, you'll see pod predicate node affinity failed. Now, I'm not an English speaker, I'm not a lawyer. For me, this is a collection of confusing words. I just don't understand, something failed. So let's see if events tell us a better story. These are examples of the events that most commonly come on these node affinities pods. And the first example refers to a config map that always existed in the cluster. It exists right now. And kubelet fails to mount this into the pod. It also shows a fresh timestamp, meaning that kubelet still tries to do something about this. And even worse, this refers to a config map that is created automatically by Kubernetes. And I don't think there is anything that you can misconfigure on your platform, on your deployment, that you can break this flow. Like this config map is created, it is there, and for some reason kubelet can't load this. Now, I don't have time for suspense, so I'll give you the answer right away, and that's here. Underlying VMs and GKE are managed in managed instance group. When managed instance group identifies a signal that some of the instance was preempted, it must remove this instance from the group. It's non-negotiable. But what it can do, it can ask for capacity back, and sometimes it will succeed. And when it succeeds, what happens is your node will continue living the cluster with the same name. For all intents and purposes, from Kubernetes perspective, that would be the same node, but the VM that is baking this node will be different, and you could see it in metrics labels and in logs. You'll see that the VM ID is different. And this is, as you can imagine, quite complex workflow. And indeed, there is issue tracker that confirms that node affinities are linked to kubelet restart edge case. They were solved for the most part in node Graceful shutdown feature, which I talked about earlier, but they were still reproducible with GKE preemptables. And preemptables are just previous generation of Spot. They have exactly the same features, except that they will always be stopped after 24 hours. It also has this important message that it is not an issue as long as you have, as long as your pod is backed by the controller. And this is because kubelet will mark this pod as failed. Failed is a terminal status, and the controller will pick it up and create a new replica. So let's see how that goes. Here we are looking at a deployment. This is a deployment, not a diamond set. At the time, it had one replica. And what we see here is a list of failed pods. You can see this status phase failed. These are out of CPU pods. And you can see here there's 12 attempts of scheduler to place this pod on this node. And node says, nope, can't do. So what happened here is it's another edge case scenario where scheduler, which is a central component, and kubelet, which is distributed component, they're running completely on different machines. They temporarily can get out of sync, and this is what happens. And this also can explain you why, when you see these pods, they come in huge amounts. And even worse than that, for 21 seconds in this example, this pod wasn't even a trigger for cluster scale-up, which potentially delays even more the recovery of this particular deployment. Now, every time, almost always when you look and you see all of these statuses and all these error ports, it's almost always not a problem in the cluster right now, but it is always an indication that something did happen in the past. So if someone comes to you in panic and asks what happens out of CPU, nothing is running, this is the only question that you should be asking yourself. Do you have enough running and ready replicas right now? So if technically it's not an issue, why do we even bother? Why is it something that took us so much time and effort? And precisely because it is not an issue, we are on platform and SRE side, we were just blissfully unaware of the effects that it had on our development teams. But our mission is to provide a platform that is easy to work with. Let's step back a little bit before we knew all this stuff, and let's put ourselves in the shoes of our customers, which are the developers. Developers, they need to deliver business logic, and they need the platform that enables them to do this fast and effective way. They deploy complex stacks that consist of multiple deployments, and if their pipeline, or rather when their pipeline fails, and usually it happens because some deployment didn't come up on time, so what do? They go to their Kubernetes client, and usually it is K9s or console, and they will see all these red words screaming at them, the exclamation marks, and all these errors that I showed you before. And particularly these node affinities, because they look like they have all their dependencies fulfilled, and they look like kubelet is still working on them, so they look like perfect candidates to blame for their timeouts. And it's really confusing and difficult, and no wonder the developers will come after us with pitchforks and torches. I would be angry myself if I had to deal with this day after day. So what are the solutions? Kubernetes provides garbage collector. Unfortunately, the threshold for it, it's configurable in upstream Kubernetes, but in GKE, this is hard-coded, and we have 1,000 objects. That's quite a lot. So we looked into deploying something that is called this scheduler. And this is quite a helpful tool, not only for spot instances, but especially for clusters that run on spot instances. It can help with a lot of concerns that are like more urgent when you're running on spot. For example, it can help to rebalance availability zones, because on spot you will end up somewhere with unbalanced clusters if you don't do this. It spreads pods of the same deployments across as many nodes as possible. And one of the policies is remove these failed pods immediately. So now all this, what I talked about, is just disappeared. We don't have this anymore. And very important, I think, is to define your critical user journeys for your platform and have an SLO on them. And why is it important? Is because this is your proof. This is data, this is metrics that tells you, or rather to your customers, that you are providing the same level of service, agreed level of service, even when you're running on unreliable infrastructure. And this inspires confidence in your in the management or in your consumers, or even in you as someone who is running platform. Now, more broadly, if we look at all the concerns of spot instances, you should be implementing these practices that are here anyways, but on spot, they're crucial. By definition, there will be more movement of pods in your cluster when you're running on spot. The good news is that Kubernetes is designed for dynamic environment and for failure scenarios, and you just need to harness this power really, really well. So always replicate your workloads. Spread them across zones and nodes. Graceful shutdown, as we spoke before, probes, and particularly startup probes, because startup is the flip coin of the termination. Something that was shut down there will spin up somewhere else, so you'll have more startups happening in your cluster. T applications by priority. Pod disruption budgets, they don't protect you from spot preemptions, obviously, but they do help to provide the overall availability of your deployment while some other pods are looking for the new place under the sun somewhere else. So with this, I think we ran out of the time, and thank you very much. And that's it. We have time for questions, I believe.